All right, welcome back. And today we are going to do a question called determine if number. So in this question, you just have a bunch of integers. And then what you need to do is, well, you have a bunch of strings and then they could be numbers or they could be not. Now, there are a lot of different kind of numbers. There are like integers, floating point numbers, negative floating point numbers, and then also like scientific notations. So what you have to do is you have to, given the constraint of what a number would look like, you would have to return if it's true or false. So let's take a look at the computer here. We have it in the comments. Here it says determine if number. So yeah, like you can see all of these numbers, some of them, like all of these are correct. And then also these ones are not correct. Like for example, 12a or 1, that doesn't make any sense. 1e1.2, exponents can only be an integer. So that's why you cannot do these. This question is less about like difficulty in terms of algorithms. It's more if you're able to catch all of the edge cases. And then if you're able to do that, it gives the interviewer signal that you're very detail oriented and stuff. So in terms of like data structures, we might not use a lot of fancy data structures, but you're gonna see that there is some ways to make your code pretty clean, and we're gonna be doing this. So first, let's talk about how we can do this, right? So the way we can do this is you have to understand that to make a number, first, there are different states that you can be in. For example, if you see a letter, if you start with a letter, that's already no, that's not a number. It has to start with a number, or it has to start with a negative sign, for example. All right, let's go on the iPad and I'll kind of talk about what you mean. So for example, here we see 1, 2, 3. And then we know that if it starts with a number, this is great. If it's a number, it's great again. And then if there's a period, then that is totally fine. Like there's a comma or period, and then because that means it's just a decimal, so you can add more numbers. However, if you add another period, then that is incorrect. Like that's not a number anymore. A number cannot have multiple periods, right? So how are you going to be able to know when you're allowed to do a period and when you're not allowed to do a period? Well, it depends on what state you're in. Like for example, if currently you've only had numbers, then yeah, a period is fine. But if you've had numbers and a period before, then another period would not be good, right? So the answer to this is you have to make kind of like a state machine. You have to have kind of like a flow chart of where you're at. For example, if you have a minus, right? Okay, that's fine. And then you have a 2, that's fine. A period, that's fine. 3, but then you're not going to be able to do another minus or another period or, or something like that, right? So that's why you have to use something called like states. Let me show you what I mean by state. So I've already drawn this. Here is what the state would look like, right? So in case if you don't understand what this means, it means if you start here, then you can go into all these different states, and depending on these states, you can land on other states, or you can go to an illegal state. And if you go to an illegal state, then it means you are not a number. But if at the end, we land on either digit 1, digit 2, or digit 3, then you are at a correct state. So what do I mean by that? Let's take an example. Let's take 1, 2, 3, right? So you start at the beginning, right? You have no number. You see a 1, so you see a digit, then you're gonna be at digit 1. So now you're gonna be at this state, right? And then once you see another number, you're gonna go back to this state, right? Because each arrow tells you what happens, and then depending on what happened, you go to a different state. So here is if you see a dot, and then digit 2 is if you see a digit from 0 to 9, and then here is if you see an E, and then for this arrow is if you see a digit from 0 to 9, and then negative. So this means if you have like a negative exponent, because after you have an exponent, you could continue having digits. So this is if you have a negative. So how does this work? So here you have 1.5e5. So first you start at the beginning state, which is this one. And then you're gonna go to one digit because you see the number 1, right? You're gonna go here. And then you're gonna see a dot. So you're gonna go all the way to the dot. And then you see another digit, which is 5. You're gonna get to here. And then you see an E, then you get to here. And then you see another digit, then you get to digit 3. And then because you landed on one of the 3 states that are valid, then you are indeed a number. All right, let's do another example. All right. imagine if your number was like 1.2.3, right? So in the beginning, you're fine. You get a digit, and then you're gonna get to digit 1. And then you get a dot, which is fine. You're gonna be in the dot state. And then you see another digit, that's totally fine. You're gonna be in a digit. But then once you see another dot, you have no more arrows to get to a state where this is valid. The only state that is valid is either having more digits or having an E, right? Now that you understand how this state works, we just have to code it. Now coding it, what you're gonna need is you're gonna need kind of like an enum, and you're gonna have a bunch of state, which is all of the ones that's listed: beginning, negative, digit 1, dot, digit 2, E, negative 2, and digit 3, right? So in some sense, this is kind of like a very big if-else statement with various conditions saying, oh, you know, am I a negative number right now? Oh, have I seen a digit before? Have I seen a dot before? Essentially, that's just what it is. But we're gonna be able to code this a lot cleaner by using these states. We'll call them digit states. And then for each of the arrows, we're gonna call them kind of like state transitions, right? From one state, you can get to another state depending on what do you see in terms of your character. All right, cool. So let's go to the code. All right, so first we have to import enum. So enum is just enumeration, just makes it a lot easier. So first we're gonna make our class. These are the different states that we're gonna call it. Let's call digit states. And then it's an enum, we inherit from the enum class. And then we have the beginning state. Like we could look back at our iPad, which is negative 1, digit 1, dot. Okay, and then now that we have all the digits, we have to show the transitions, right? So we're gonna make this a dictionary. So it's kind of like a graph where the keys are going to be the node, which is the state, and then the values is going to be an array of other states that you can get to. So basically these are arrows or kind of like edges. So let's do that. So I already wrote this, so I'm gonna just copy paste this. So as you can see here, we have all of these different states that we listed before. And then in terms of value, it's about the states that you can go to. So if you look at the iPad, you're gonna see that in the begin state, you can go to either negative 1 or digit 1, right? Okay. So now the other thing that we have to do is we have to actually define what the arrows actually mean. It means like, what do you see so that you go to a certain state, right? So how we're going to do that is we're going to define lambdas, which is just non-named functions. And these functions will be a Boolean function where it tells you true or not. So we're going to give you a state, and then depending on that state, we're going to say, how am I going to land there? Like what would have to happen for me to land there? For example, the state dot, I would have to see a period so that you could land on dot. Or digit 1, you would have to see a integer 0 to 9, or like a digit from 0 to 9 for you to get to that state. All right, so let's do that. And then I have it written already. So here's the digit lambdas. So for me to explain it, so here, begin, you always start at the beginning, so it's gonna be true no matter what. And then for negative, this is only true if the character that you see is a negative, right? And then for digit 1, it is only true if it's a digit, right? So that's why these lambdas are doing, it's only like to return a Boolean. And then for dot, it is only true when you see a dot. And then same thing for 2, E, it's only true if you see a character E. All right, cool. So now let's get to the actual function. So the actual function will be quite simple, right? So the actual function, we'll call it parse number. And then here you're gonna have a string, and then we'll call it S for string. And then what we do is we assign the first state. The beginning state would be the begin state, right? So now we have that. So what are we gonna do next? We're gonna be parsing through every single character on the string, and then we're gonna see if we, depending on what character it is, you're gonna be calling the digit lambdas to see if you can go to those next state that you want to go in, or you're gonna see which state you're going to go in, and then you're gonna record your state, and then until at the end, you either get out of the state, which means it's not a number anymore, or you finish the state, and two things can happen. Either you're in a non-final state, like for example, negative, dot, E, those are non-final states, or you're in a final state. which is like digit 1, digit 2, and digit 3, which are good states that can be valid. All right, let's do that. So we're gonna have a found next state. This variable allows us to know if we have gone off track of our state machine. And then if it does, if it's false, then if we can't find anything anymore, then it means it's not a number. Okay, for next state in, so remember we had a dictionary, FSM, right? So that means I want to know, this lines means I want to know the state that I'm at right now. What are all the other states that I can get to, right? And then with all these states that I want to get to, I want to see if it's possible given what character I am looking at right now. So I'm gonna loop through all of the states that I can go to and see what kind of function I need. And those functions are basically a Boolean function to tell you if you can or cannot get there. All right, next state character. So here I'm calling the lambda function. And then if it's true, great, we found the state, right? So if you found the state, then you're gonna say true, and then you update your state also. And then that's it. You break out of the loop and you're done, right? So this, what happens if you don't break, then it means you're gonna have to, it means you've looped through everything and then you haven't found a next state that is possible. If you didn't find a next state that is possible, then you return false because you're not a number. All right, cool. At the end, once you've looped through all the characters, there's a few things that can happen. Either you're not in a valid state. If you're not in a valid state, then you return false. If you are, then you return true. And the only valid states are the ones that are called digits. Those were the green state in our iPad. So I probably have some typos, so I'm just gonna run. So now we can try to test them. Let's see if it works. So print parse number 12.3, this should be right. And then another one, parse number, let's see, 12a, this should be wrong. Okay, excellent. So yeah, this is supposed to be true, this is supposed to be false, and this is what we get. We can try another one if we want. So let's take all of these examples. -1.23, let's try -0.3. Let's try 1.5 E5. These are supposed to be all true. Okay, excellent. We'll try some of the ones that are supposed to return false. 12a, 1 space 2, 1E 1.2. Excellent. So there you go, this works. And the time complexity. So the time complexity should be pretty simple because you're going through all of the characters in the string. So that means is O of n, where n is the number of character in the string. All right, thank you so much. See ya.